Okay, so let's look at the next example. So number 2, it says an object is projected vertically upward from the top of a building with initial velocity of 112 feet per second. Its distance, s of t, in feet above the ground after t seconds is given by the equation s of t equals negative 16t squared plus 112t plus 110. And we want to find its maximum distance above the ground and also find the height of the building. All right, so again, this is a lot to take in. My suggestion, as always, will be to draw a picture of what's happening first, and then you can go from there. So what's happening? We have some type of object on top of a building, and it's projected upward, and so we know it's going to come back down, right? So it's going to look like a parabola. All right, so I'm going to draw my building. Don't forget we have a building. And this is the ground. All right, so we have some type of object on top of our building. I'll just draw it like a little bitty puff. We have our object, and it's projected up, which we know gravity is going to make it come back down, right? We have a parabola. Okay. All right, so I want to go ahead and also pretend like this is an x and y axis, just like before. But instead of x, what are we using here? What's the thing going into our equation? T, and then up here we have s of t, or just s if you want to call it. Where s is the feet above the ground. All right, so I'm going to write that down so we remember. Alright, so everything on this, what's like our y-axis, tells us the feet above the ground, and t is just our time in seconds. So we always want to start at time equals 0, so this is our 0, and then move forward in time. Okay, so this is our picture. Hopefully this can help us answer the question. We already have an equation, so hopefully that will work and help us as well. Let's start with part A of this question. It says, find its maximum distance above the ground. All right, let's go back to our picture. This is the distance above the ground. Where would the maximum be located? Well, it would happen at the vertex, right? So the y value or the s value of our vertex is the maximum distance above the ground. So that means we need to find the vertex. Okay, and so we could go through the whole process of rewriting this in standard form, or if you remember, I gave you all a shortcut to help us find the vertex when we're not in standard form. All right, so if you remember, to find h, it's negative b over 2a. And so what are a and b? Well, it's based on the equation of our quadratic function or our parabola. So here, a is negative 16, b is 112, and c is 110. Okay. All right, so negative b, so negative 112 over 2 times negative 16. I'll do the math for us. It's 3.5. All right, so that's the k or x value or t value here. So I can write that down here. This happens at t value 3.5 or 3.5 seconds. And the part we really want is our k, or our height above the ground. All we have to do is plug in our x value or our t value into our function and we'll find it. S of 3.5. Right, so we just plug in that h into our function and we'll have the other part of our vertex that tells us the height. So this is 306. So this is the point 3.5 and 306. So now, could you tell me the maximum distance above the ground? Do we know this height? Yes, it's 306 feet. All right, so the vertex tells us things about the maximum. So whenever you see maximum value of something that's a quadratic, you always want to think about the y value of the vertex. Very important to remember. Okay. Part B says find the height of the building. All right, so height of the building. So we're still on this y or this x axis here, and we want to figure out what is the height. What is the y value right here? Well, do we know the x value or the time here? T equals 0. Hopefully we should be able to use that to find the height. So let's say to find the height of the building, we just need to find where t equals 0. So we just need to find s of 0. So 110 feet is the height of our building.